In this video, we will be looking at rational equations. We're going to start by looking at linear equations with fraction coefficients. So first we have 2/5 x minus 4 is equal to 12. The first thing I'm going to do is I'm going to move that 4 over because that's going to make this equation a little bit simpler. If I add 4 to the other side, I'm going to have 2/5 x is equal to 16. At this point, we have a few options for what we could do. So I'm going to look at a different example for just a minute, put this one on pause so we can figure out what we're going to do with it. If I had 2x equals 4, then I would divide both sides by 2 and I'd get x equals 2. So one thing I could do is divide both sides by 2/5. And 16 divided by 2/5 is something I can put in my calculator. It would give me x is equal to 40. That's fine and dandy, it works, it's wonderful. But another thing we know is that dividing by a fraction is the same as multiplying by the reciprocal. So looking back at this 2x equals 4 example, instead of dividing by 2, I can multiply both sides by the reciprocal of 2, which is 1/2. And that'll give me x is equal to 2. Looking at the example I was given, if we have 2/5 x is equal to 16, I could instead multiply by the reciprocal of 2/5, which is 5/2. And that will still get me to x equals 40. So it doesn't matter how you go about it, as long as you're getting rid of that coefficient on x, we're in a good place. Next up, we're looking at x minus 12 over x is equal to 4. I've taught this a few different ways in the past, and the way that seems to stick best with most people is to get all fractions to have the same denominator. And not just all fractions, but all terms. So I want all of my terms to have a denominator of x. Right now, if I make them all have denominators, I have x over 1 minus 12 over x equals 4 over 1. So if I want them all to have a denominator of x, I will have x times x over x minus 12 over x equals 4x over x. So I'm multiplying the first fraction by x over x. I'm multiplying my right side by x over x. The reason I'm doing this is so I can now multiply both sides of my equation by that denominator that they all have in common. So I'm going to multiply both sides of this equation by x because it is that denominator. What that's going to do is it's going to divide out with all of my denominators, and I'm just going to be left with the numerators. X times x is x squared minus 12 is equal to 4x. I can move the 4x over, giving me x squared minus 4x minus 12 is equal to 0. That's going to factor into x minus 6 times x plus 2 is equal to 0, giving me x equals a positive 6 and x equals a negative 2. Those are my two solutions. The one thing you need to be really, really careful of with rational equations is that you have to be sure to plug your answers back in to make sure they work. So I need to plug these back into my original equation, x minus 12 over x equals 4, to make sure they work. So first up, we would have 6 minus 12 over 6 equals 4. That's 6 minus 2 equals 4. That checks out. That's good. For the other one, we'd have negative 2 minus 12 divided by negative 2 equals 4. That's negative 2 plus 6 equals 4, and that checks out as well. So we get two solutions on this one. So that's just something to keep in mind, is we have to check our answers. No dividing by 0 here. Next up, we have a 1/3 x plus 1/4 is equal to -1 times 1/2 x minus 2. I'm going to go ahead and distribute my -1 through the parentheses. That way I can clearly see what's going on. I have a 1/3 x plus 1/4 is equal to a -1/2 x plus 2. And all I did there was multiplied through by my -1. Now, since I have so many different fractions going on, I want to get these all to have the same denominator. So I'm looking at a denominator of 3, a denominator of 4, a denominator of 2, and a denominator of 1. So I need to figure out what denominator I can change those all into. So the smallest number I can think of that is divisible by 3, 4, 2, and 1 is 12. So this first fraction I'm going to multiply by 4 over 4. My 1/4 I'm going to multiply by 3 over 3. My -1/2 I'm going to multiply by 6 over 6. And my 2 over 1 I'm going to multiply by 12 over 12. And we'll see what happens there. That will leave me with 4/12 x plus 3/12 is equal to -6/12 x plus 24/12. That way all of my terms have a denominator of 12, and then I can multiply both sides of my equation by 12, and that 12 divides out all my denominators. Poof, no more denominators. I'm left with 4x plus 3 is equal to -6x plus 24. I add the 6x over, giving me 10x. I subtract the 3 over, gives me 21. And I get x is equal to 21 over 10. But remember, we do want to check our answers. I'm going to show you one way to do it if your calculator has a fraction button. If not, you're just going to have to type it in as 21 over 10 in parentheses. But if you do have a fraction button, this isn't too bad. So I have 1/3 times my fraction 21 over 10 plus 1/4 equals 57 over 60. Now I need to check the other side. -1 parentheses, the fraction 1/2 times my fraction 21 over 10 minus 2, close the parentheses, 19 over 20. So last time they gave me 57 over 60. But if I simplify that, whoops, it takes me to 19/20. So both ways, I got 19/20. So that means I got the right answer because I got the same value on both sides of the equation. So we are looking for x equals 21/10. Next up, we're looking at 7 is equal to 10 over x plus 1. And I'm going to teach you something really cool, super awesome, that makes solving certain rational equations really easy. It's called cross multiplication. The problem with cross multiplication is that it only works if you have fraction equals fraction. So if we have a over b equals c over d, then we can multiply numerator times opposite denominator, a times d, and that will be equal to the other cross, b times c. This is super great because it saves us from really thinking about fractions too much, but it works because we have this ability with fractions to establish a like denominator and multiply through by it. Well, it doesn't look like I'm looking at fraction equals fraction, but if I call this 7 a 7 over 1, then I do have fraction equals fraction. If I do my cross multiplication, I'm going to have 7 times x1 is equal to 1 times 10. And that equation seems a whole lot easier to work with than what I started with. Distributing my 7 through, I get 7x plus 7 is equal to 10. Subtract the 7, 7x is equal to 3. Divide by 7, x is equal to 3/7. I'm going to go ahead and check my answer again just to be sure. We have a fraction 10 divided by, my x value was 3/7. And that needs to be plus 1 equals 7. Hey, it checks out, yay. You should be getting suspicious that one of these isn't going to work out sometime. We've got another one. 7 equals 2 plus 10 over x plus 1. This one's not fraction equals fraction, so we cannot use cross multiplication. But we could if we subtracted the 2 over. If I subtract 2 from both sides, I have 5 is equal to 10 over x plus 1. And then if I write my 5 as 5 over 1, then I can cross multiply because I have fraction equals fraction. That'll give me 5 times x plus 1 is equal to 1 times 10. Now it looks very similar to the last problem, we just have a 5 instead of a 7. That'll give me 5x plus 5 is equal to 10. I subtract the 5 over, 5x is equal to 5. Divide both sides by 5, we get x equals 1. This one we can kind of plug in our head because if x equals 1, then this denominator is 2. 10 divided by 2 is 5, and 5 plus 2 is 7. So this one checks out. Cool. Let's check out a real fraction equals fraction. So we have r plus 4 over r is equal to 15 over r minus 4. I'm going to cross multiply. So I'll have r plus 4 times r minus 4 is equal to r times 15, which is 15r. I need to FOIL the left-hand side. That'll give me r squared minus 4r plus 4r minus 16 is equal to 15r. Combining my like terms, that's r squared minus 16 equals 15r. This is a quadratic equation because it has an r squared, so I need to get all of my terms on one side. So I'm going to subtract that 15r over. That gives me r squared minus 15r minus 16 equals 0. I'm going to go ahead and factor that into r minus 16 times r plus 1. That gives me r equals a positive 16 and r equals a negative 1. So if we plug in 16, let's see what that would do. That'd be 16 plus 4 is 20 over 16 is equal to 15 over 16 minus 4 is 12. So we need to know if that's true. Well, 20 over 16, if I divide by 4, that gets me to 5/4. 15 twelfths, if I would divide by 3, that gets me to 5/4. So 16 checks out. If I plug in negative 1, then I'll have negative 1 plus 4, which is 3 over negative 1, is equal to 15 over negative 1 minus 4 is a negative 5. Negative 3 equals negative 3, so that one checks out too. Cool. We have two solutions, r equals 16 and r equals a negative 1. All right, so we can only use cross multiplication if we have fraction equals fraction. That is the only time. But it is very powerful, it's very useful, and it tends to make things a whole lot easier. Next up, we're looking at 9 over n minus 2/3 is equal to 3 over n. I don't see fraction equals fraction here. I could subtract 9 over n from both sides and get it to be fraction equals fraction, but I want us to remember what to do if we don't have fraction equals fraction. In that case, I want everything to have the same denominator. So I have n, 3, and n. So I can make all of these have a denominator of 3n. In my first fraction, I'd have to multiply by 3 in the numerator and denominator. In my second fraction, I have to multiply by n in the numerator and denominator. In my last fraction, I have to multiply by 3 in the numerator and denominator. When I do that multiplication, I'm looking at 27 over 3n minus 2n over 3n is equal to 9 over 3n. Once they all have the same denominator, that's when we multiply by that denominator to make everything go poof. And I no longer have any denominators because that 3n divides out with all of them, giving me 27 minus 2n is equal to 9. If I subtract the 27 over, I get negative 2n is equal to a negative 18. And dividing by a negative 2, I get n equals 9. This one's actually pretty easy to check by hand as well, because we'd have 9 over 9 minus 2/3 is equal to 3 over 9. Well, that's just saying 1 minus 2/3 equals 1/3, which we know is true. So n equals 9 checks out. Okay, so we've worked all this up to say we have to check our answer, but all of our answers have worked. Is there a time when our answer doesn't work? Of course there is. So we're looking at 1 over x minus 2 plus 1 over x plus 2 equals 4 over x squared minus 4. Thinking back to the last section, when we were just simplifying rational expressions, we need to find a common denominator that will work for these. So our first denominator is an x minus 2. Our second denominator is an x plus 2. Our third denominator is x squared minus 4, which factors into x plus 2 times x minus 2. So this last denominator is already my least common denominator. I just need these first two fractions to get there. So my 1 over x minus 2 needs an x plus 2 in the numerator and denominator. Plus my 1 over x plus 2 needs an x minus 2 in the numerator and denominator. That's going to be equal to my 4 over, in factored form, I already have x plus 2, x minus 2. So they now all have the same denominator. I'm going to multiply both sides of my equation by that common denominator, x plus 2, x minus 2. By multiplying by that denominator, all the denominators go poof because they divide out. I'm left with 1 times x plus 2 plus 1 times x minus 2 is equal to 4. Distributing through, x plus 2 plus x minus 2 equals 4. 2x equals 4. X equals 2. The problem comes when we try to plug it in. Our very first fraction, if we plug in x equals 2, is 1 over 2 minus 2, which is 1 over 0. You can't do that. Dividing by 0 is bad. So this is not a solution. If that's not a solution, then I have no solution. So this rational equation does not have a solution. That is totally possible. Do keep in mind that there were some rational equations where we came up with 2 answers. When you go back and plug them in, if one of them works and one doesn't, you still get to keep the one good answer. You only throw out the ones that are bad. With rational equations, make sure everything has the same denominator, multiply through by that denominator, and then solve your equation and make sure you plug in your answers to make sure they work.